Assalamualaikum. So today I'm going to show you the result that we get from this impact object experiment. Right. I'm using this Excel application software. The first layer, the first worksheet. We describe about the equipment that we use. We have the manufacturers and the model, and then the figure as well. And then the name of this equipment is given on the left hand side. We have electronic balance, AND and model, and some picture that I can get from the internet, from the web. And then we have impact jet apparatus from solution engineering stream Rahat. These are models, and you can see this is the set up for that experiment. And then we have hydraulic bench solution engineering stream Rahat from Soltec model FM110. And then we are using the quartz clock from NACO. The model is NA6130. And then the next worksheet is the parameters, and then for these parameters we define the fluid property, and these are variable that does not change during the experiment. We have to calculate the density of the fluid. Previously we already used the electronic balance and the volumetric cylinders to obtain the values for the specific volume that we use. And then we have the mass of that fluid, 300 milliliter fluid, and then from there we can get the value of the density of the fluid. And then the fourth property here is dead weight. This is the dead weight that we're going to fix, and this is the accurate value that we get from two mass, and we're going to maintain the same value throughout the experiment. And then the numerical properties here, we just mentioned about the reference pointer will be set at 90 mm. And then we are using also the constant variables, which is gravitation acceleration is set at 9.8 meter per second. Right, this is the third worksheet. Right, so these are two nozzle diameter that we use. 5 mm diameter nozzles and 8 mm diameter nozzles. So we have a surface description given by the 30-degree flat, 0-degree flat, hemispherical, and 120-degree cone. From our observation, there is some manufacturer defects on our equipment, on our apparatus that don't allow us to do the experiment, and we only cover only two geometry, 0-degree flat and hemispherical. So in this column, we set the initial volume and final volume in order for us to determine the filling period. Similarly, we do the same for the 8 mm case. So for 0-degree flat, the initial volume is 0, and the final volume is 5 to get 5 liters, and our filling period is 1 minute 27.57 seconds. When we are using hemispherical, the initial volume is set at 0 and final volume at 5, and the filling period is 1 minute 37.60 seconds. And then we change the nozzle with 8 millimeter diameter. For 0-degree flat, the initial volume was set at 3 liters and ended at 8 liters, and the filling period is 24 seconds. And for hemispherical, the filling period is much more longer, but we start at different initial volume, which is 1 liter, and then we ended at 6 liters. So these are the information that you're going to use to write a report for this experiment. And the reason why we decided not to do experiment for a 30-degree flat surface and 120-degree cone surface will be given after this. And this is the cone surfaces, and as we increase the flow rate, what we observe that the pointer is, instead of going up, is moving downwards. This is because the water is start to filling the upper part of the piston, and it brings down the weight further. So we're not going to do the measurement for cone and 30-degree flat surface because of this the problem that we have when the feed is entering the upper part of this cavity. This is the behavior of fluid for 30-degree flat surface. Right. So right now we have only one that mesh, and the pointer is returned back to the reference elevation. And if we add additional mesh, and the pointer is moving about one resolution by increasing mesh, right? So the water starts to filling the piston up, the surface of piston, and it affects the pointer location. It drops suddenly and the water increase so much. So this the area that we have right now is not because of the measurement, but because the water is filling the upper part of the piston.